Good morning, student. Today we discuss D block element, and you also know D block element is very important for the board examination. But before starting, we try to understand what is different element and how these elements are present in D block. Let us go. D block element. D block elements. D block elements. Actually, D block element is also known as transition metal element. Transition metal elements. Okay. What is D block element? You can explain. The D block elements. The D block elements are those whose last electrons enters in the subcell. In other words, we can say that D block elements are those whose general electronic configuration is ns2 n-1 d1 to 10. D block elements are those whose last electron enters in D subcells, or D block elements are those whose general electronic configuration is ns2 n-1 d1 to 10. Actually, D block elements are also known as transition metal elements. It is also known as transition metal elements because these are present in between S and P block. It means that D block elements is also known as transition metal elements because its property is present in between metal and non-metal, because in periodic table these are placed in S block, in between S block and P block elements. Okay. It is one question which is asked in board examination, that why D block element is known as transition metal element. Then you can easily explain it. Second, what is the type of D block elements? Types of D block elements. All the D block elements are categorized into four category. First transition series elements or 3D transition series elements. Second transition series elements are 4D transition series elements. Third transition series element. Third transition series elements are 5D transition series elements. And last is fourth transition series elements are 6D transition series elements. Okay, in this classification it is clear that all the D block elements are categorized into four categories, in which first is known as first transition series element or 3D transition series element because its last electron enters in 3D subcells. Second transition series elements also known as 4D transition series element because its last electron enters in 4D subcell. Third transition series elements are those whose last electron enters in 5D subcells, therefore it is also known as 5D transition series elements. Fourth transition series elements are those whose last electron enters in 6D subcell, therefore it is also known as 6D transition series element. You can write it easily in your examination hall, and after this type of discussion we try to understand that what is first transition series element and what is its properties. First transition series elements are those whose last electron enters in 3D subcell. It means that first transition series elements are those whose electrons enters in 3D subcell. 3D subcell. The general electronic configuration of first transition series elements is 18 argon 4s 2 3d 1 to 10. 3d 1 to 10. It is the general electronic configuration of 3D transition series elements. Actually, first transition series, it means that these series of elements, means first transition series of elements having 10 elements starting from 21 scandium to 30 zinc. There are 10 elements are present in case of first transition series elements, and we can easily discuss all type of property of first transition series element according to this classification. All the D block elements which are categorized in 4 category, but first transition series which have 10 element starting from scandium, titanium, vanadium, chromium, 21, 22, 23, 24, manganese, iron, cobalt, nickel, copper and zinc. You can easily see here, these are 10 element: scandium whose atomic number 21, titanium whose atomic number 22, vanadium whose atomic number 23, chromium whose atomic number 24, manganese whose atomic number 25, and iron whose atomic number 26, cobalt having atomic number 27, nickel whose atomic number 27, copper whose atomic number 29, and zinc whose atomic number 30. If we discuss all type of characteristic of these element, then firstly we discuss about the electronic configuration. The general electronic configuration means outermost electronic configuration of these element can be explained as 21 scandium whose outermost electronic configuration is 18 argon 4s2 3d1, titanium 23, whose general electronic configuration is 4s2 3d2, vanadium 23, its outermost electronic configuration is 4s2 3d3, 24, chromium 18, argon. Here 4s2 become 4s1 and 3d4 become 3d5 according to Hund's law of electronic configuration. Half filled orbital are more stable as compared to other, and it become half filled, and its electronic configuration just differ according to previous. It become 4s1 3d5. 25, manganese, whose electronic configuration argon 4s2 3d5. After manganese, iron 26 and its electronic configuration argon 4s2 3d6, cobalt 27 and its electronic configuration 4s2 3d7, nickel 28 and its electronic configuration 4s2 3d8. But in case of copper, which contains 29 number of electron, these electrons are arranged according to Hund's rule and it's become 4s1 3d10. And zinc, whose atomic number 30 is equal to argon 18 4s2 3d10. In first transition series, all these elements are present. In first transition series, all the elements are present in between S and P block, starting from third period and group number starting from 3rd to 12. It means that all these elements are first transition series elements, but zinc, although present in transition metal elements, but it is not transition metal elements. It is known as only d block element, but it is never known as transition metal elements because its d electron, d subcells or d orbitals are completely filled. Thus, it unable to exchange their d electron. Therefore, these are known as non-transition metal atom of first transition series. Except this, all the elements are present in transition metal elements. And another property of first transition series elements are known as atomic or ionic radius. We also know that second is atomic radius or ionic radius. You also know that the distance from nucleus to outermost cell is known as atomic radius of any atom. But if there is any ions are present, no matter they cation or anion, but in case of transition metal elements, all the elements are cationic because they can lose their electron. It is also known as good metal because of s electron which is present in d block element, and due to s electron it can easily donate their electron and show the property of metals. Thus the distance from nucleus to outermost cell is known as atomic radius, but these are present in the form of ion, then it is known as ionic radius. What is the discussion about radius? You can explain it. All the 3D transition series elements are present in third period, and you can see here all these elements contains only 3 cells. Due to presence of 3 cells from scandium to zinc, only 3 cells are present, then its distance from nucleus to outermost cell is not increase, it constant. Due to constant distance between nucleus and outermost cell, it never increased their atomic radius as we move from left to right in third period of the periodic table. But number of electron increases due to increasing the number of electron in third period, and if number of electron increases, then its atomic radius decreases. 22, 23, 24, 25, 26, 27, 28, 29 and 30. You can see here from 21 to 30 electron continue increases as we move from left to right in third period of the periodic table. Then its number of electron increases, but number of cell are never increases. Thus you can say that the atomic radius decreases. But in case of ionic radius, if we see here, then due to donating property of the different type of element of 3D series, firstly atomic radius decreases, but after manganese the atomic radius gradually increases. Ionic radius gradually increases, not atomic radius. The ionic radius firstly decreases and then increases due to extra electron present in D subcell. Okay, I hope you betterly understand what is the effect of atomic radius on 3D transition series element. But if we try to understand the oxidation state, then you can explain the total number of outermost cell electron which can lose all the 3D transition series show their oxidation state, and scandium, titanium, vanadium, chromium, manganese, iron, like cobalt, copper and zinc. The oxidation state of scandium +2 or it may be +3. The oxidation state of titanium starting from +2, +3 and it show +3 oxidation state. Vanadium starting from +2 oxidation state, +3, +4 and +5, because it can lose their 5 electron. But in case of chromium, starting from +2, +3, +4, +5, +6 and manganese 25, starting from +2, +3, +4, +5, +6 and +7. The oxidation state of manganese starting from 2 and goes toward +7, and after +7 oxidation state. In case of iron, the oxidation state decreases starting from +2, +3, +4, +5 and +6. Here you can see here the total number of 1, 2, 3, 4, 5 orbital is present in d orbital. Iron, which contains 3d 6 electron and 4s2 electron, if we fill all these 6 electron, then total number of unpaired electron here equal to 4 and s contains 2 electron. Then it can donate these s electron and 4 d electron. Thus total oxidation state is equal to 1, 2, 3, 4 and 2 is equal to 6. Therefore starting from +2 and move toward +6. But in case of cobalt, if 1 electron increases, 3d6 become 3d7. It contains only 3 electron in d orbitals and 2 electron in s orbital. Thus +2, +3, +4, +5 oxidation state shown by the cobalt. But in case of copper, whose total number of electron is equal to 1 and 2, thus oxidation state become +2, +2. And in case of zinc, it can donate only s electron, therefore its oxidation state is +2. And on the basis of these oxidation state, you can say that the most stable oxidation state of 3d transition series is +2 and +4. Less oxidation state is +5 and least oxidation state is +6 and +7. But stable oxidation state is +2 or +3 in case of 3d transition series. +7 oxidation state only shown by the manganese due to presence of 7 number of electron in his outermost shell. Okay, I hope you betterly understand why they show variable oxidation state. One question arises here, why d block elements show variable oxidation state? You can explain in one word that due to different unpaired electron, it show variable oxidation state. Due to different unpaired electron, it show variable oxidation state. Okay, after the knowledge of oxidation state, we try to understand what is the magnetic properties. What is the magnetic properties? Fourth is magnetic properties. What is the magnetic properties of 3D transition series elements? You can explain all type of those 3D transition series which have paired electron in his outermost shell are always diamagnetic in nature. The element which contains paired electron in his outermost shell is known as diamagnetic in nature, while the element with unpaired electron is paramagnetic in nature. Paramagnetic in nature. There are two types of property explained. First is diamagnetic, second is paramagnetic. After this type of discussion, we also try to understand that what is high spin complex and what is low spin complex, because it shows another property for the complex formation. All the d block element can form two type of complex. First is low spin complexes and second is high spin complexes. Low spin complexes and high spin complexes. Low spin complexes are those in which the number of unpaired electron is less than 3. Okay, less than 3, and it contains less than 3 electron in his outermost shell. Less than 3 unpaired electron. You better explain. It contains less than 3 unpaired electron. Unpaired electrons. Okay. High spin complexes are those which have 3 or more than 3 unpaired electron. If any transition metal element have more than 3 unpaired electron, then it is known as high spin complexes. But some complexes are colored and some complexes are colorless. Then another property of these elements is that the 3D transition series have a property to form colored or colorless compound. You can explain why 3D transition series element form colored complexes or colorless. Then you can explain that all type of those complexes in which DD transition are possible always form colored complexes, and all type of those transition metal element in which DD transition are not possible, so colorless complexes. Here one question arises: what is DD transition? You can see that you can explain it well, that if any elements have number of unpaired electron, then it shows DD transition. If any transition metal elements have either paired electron or zero electron in d subcells, then it always show colorless complexes. And after this type of discussion, one thing is also very necessary for you, that you know what is the enhanced value of magnetic moment. Okay, the magnetic moment, which is explained on the basis of this formula, mu under root 2 n plus 2 bm. Bm means Bohr magneton, 2 n plus 2 under root, mu is equal to, if we know what is the n is the number of unpaired electron. Okay, if we put the value of unpaired electron, then we can easily understand what is the magnetic moment of any elements or complexes. Okay, if any complexes have less than 3 electron, then its magnetic moment is low, but if any complexes have more than 3 unpaired electron, then its magnetic moment is high. Okay, one thing is very necessary for you, that all the 3D transition series elements show catalytic properties like nickel, copper and iron, manganese, chromium. These are the elements which are generally used in the form of catalyst. Okay, and catalysts are those type of substances which can change the rate of reaction or affect the rate of reaction. They can be increases or decreases. And my next lecture in my next video. Thank you so much.